Hello. In this video, I'm reviewing question 5 from the 2021 final exam for ACST1052. So in this question, our main character, Ebenezer, has $1, lucky for him, that he wishes to invest in two alternatives. So either he invests in gold, which in this question is considered to be safe, providing a modest return of 3% per year, but taken to be constant, so 3% every year. Or you can invest in a factory that produces Christmas toys. In this case, the return is more variable. So you might get 1%, and this happens with probability 40%, or you might get a better 5%, and this happens with probability 60%. So here there's randomness. So he has a utility function given as follows. First of all, show that Ebenezer is risk-averse. Describe in words the behavioral properties of risk-averse investors. So that's not especially a hard question. If you take the first derivative here, it's going to be positive, meaning that the function is increasing. But then you take the derivative of the derivative. So of course, this is the second derivative, and you'll get something that is negative everywhere. This means that the function is increasing, but at a decreasing rate. So you know the utility function here is concave. That's exactly the criteria we saw to determine that someone is what we call risk averse. So, well, that's a terrible axis, but here, if W is 0, then his utility will be 0. Otherwise, it's going to be increasing, but at a decreasing rate. Okay, something like this. And then I think that's about it. That way, they ask you to explain in words what it means to be risk averse. Well, a risk averse investor needs to be compensated for taking on risk as and he experiences diminishing marginal utility. That's true. We might have said between two options, one which is a fixed amount of dollars, let's say X dollars, and the option where you might have variable wealth, and on average, so the expected value of this wealth is X dollars, the risk-averse investor prefers the fixed X dollars. But of course, it becomes more complicated if there's a variable amount of wealth that on average is worth more than X dollars, then maybe this person would prefer this option compared to a fixed X dollars. Then you need to make the calculations. Okay, now this is what we do here. Determine, showing all workings, which investment Ebenezer would prefer. So it's not a complicated calculation. If you invest in gold, then you will have a fixed amount of money at the end of the year, right? So you will have, it starts with $1, you will end up with $1.03. So the utility here, there's no expectation calculation. It's just going to be the utility of a fixed number of dollars. In this case, the utility gives you this 0.6430. If you invest in the factory, then there's randomness. So then you need to compute the expected value of the utility of the wealth. In the case he gets the factory. Okay, but this is not hard to do. You just multiply the probabilities. Okay, with 40% chance, he's going to get an amount of dollar which is 1.01. So then, of course, he gets a utility of wealth of U of 1.01 plus 0.6 of U of 1.05. And you make this calculation, you see there's this number is bigger than the previous one. So he would prefer to have to invest in the factory in this case, because the expected utility of that option is bigger. And then, and you see, I think this is an example where the answer was not entirely trivial. Just let me get my calculator, because if you had computed what's the expected value of his wealth, the wealth, not the utility of the wealth, in the case of investing in the factory, you see you would have gotten 0.4 times 1.01 plus 0.6 times 1.05, which would give you a number that should be a bit bigger than 1.03. And yes, it's 1.034. So you see here, the expected value in the case of investing, expected value of the wealth is bigger. So then there's a possibility that you might prefer this. And yes, this is what we have confirmed with the utility calculation. My point is just that if you had gotten a number here smaller than 1.03, then you would have concluded directly that they will prefer the fixed option because they're risk averse. But in the case where the expected utility is bigger, then you need to make the calculation to see which one he does prefer. Okay, part C here, I've made some annotation and I wanted to explain a bit. By the way, maybe I should get in full screen so we get a better learning experience. So part C, let's read the question. And again, I'm going to explain my annotations after that. If Ebenezer chooses to invest in the factory, okay, and here let's just ignore what we've done before. I assume he invests in the factory. So he also decides to purchase insurance for the factory, which will repay the entire value of the loss in the event that the factory is destroyed, including investment returns. Now, the factory has 1 in 10 chances of being completely destroyed through spontaneously explosion at the end of the year. It should be spontaneous explosion, right? This is poor grammar, but anyway. Just after finishing production. Now here, I just added a sentence. I think if I had written this question, I think I would have pointed out clearly that this means he loses the entire value of his investment, meaning he started with $1. If this 10% chance event happens, then he's going to lose his dollar. He's going to have 0. And here the question tells you that the insurance means that if he gets the insurance, he will recover his $1, but also the investment. So we're back to the case where he's going to have $1.01 with certain probability and $1.05 with a certain probability. Now derive an equation that needs to be solved in order to obtain the maximum premium that Ebenezer is willing to pay P. So here we cannot really find P because it's a equation that's hard to solve, but the question is to find the actual equation that you need to solve. So let's make the calculation. First, if Ebenezer does not purchase insurance, the expected utility will be. Now here you need to consider the 2 things. There's the event the factory is destroyed, but then independently of that, there's the event making a given yield, a given return or not. What we mean is that, okay, if the first here, this is the event, 10% chance is the event the factory is destroyed. If the factory is destroyed, as we said, he loses everything. So then he will have a wealth of 0, so his utility will be just U of 0. Now, if the factory is not destroyed, and this happens with probability 0.9, but then there's still 2 cases to separate. The probability makes the small return, and the probability makes a bigger return. So here, implicitly in this calculation, 0.9 times 0.4 is this over here. We're looking for the probability the factory is not destroyed, and also the return is 1%. Here, they don't say explicitly, but when it's not said explicitly, you can make the assumption that those events are independent. So if we're looking for the probability factory is not destroyed and the return is 1%, then you can use probability of A times probability of B. Okay, the probability of the intersection of independent events is just the product of those probabilities. Of course, what I call A here is factory is not destroyed, and what I call B is getting a return of 1%. So the probability of this is 0.09 times 0.4. And in that case, if this combined event happens, they will have a wealth of 1.01 at the end. Also, of course, there's another possibility, which is that the factory is not destroyed and they make a return of 5%. This event has probability 0.9 times 0.6, in which case they get a wealth at the end of 1.5. Okay, so you compute, you plug those numbers in the utilities and you get this number, which not surprisingly 0.579 is smaller than the number we had before. So of course now there's a probability he loses everything, which destroys his utility. So that's the option with no insurance. Now, if he does buy insurance, then what happens? Well, he's going to pay the premium, and this is what we're trying to find. He's going to pay the premium, but then he's protected because in all cases, he's going to make a return. Now, careful that there's still uncertainty in that option because he pays a premium. So the factory, if it is destroyed, is going to get reimbursed. But there's still uncertainty about how much the factory is making. You know, what's the return on the investment? So in this case, you would find expected utility of the second option with insurance. To be honest, I think this this part here is a bit unnecessary. I think it would be fine to jump straight away to this line, meaning, okay, he has insurance now. So the only thing that's uncertain is the yield that the factory is going to make. So with 40% chance, again, his wealth is going to be 1.01, but he pays a premium this time. Okay, so his final wealth will be however return he has on the factory minus the premium. And likewise, with 60% chance, he's going to make the bigger return, 5%, but also he needs to pay the premium. He pays the premium no matter what in this case. Okay, here, the first line is just writing, again, using the conditional probabilities. Okay, if the factory is destroyed, that happens with 10% chance, and the return is 40%, then he's gonna make well, in this case, he's gonna still make 1% because remember, he has insurance now, so the insurance reimburses whatever he would have made. But again, of course, if you simplify this bit, you get exactly this bit that I think you could have just written straight up. Because obviously, my point here, sorry if I'm giving too much explanation on the same thing, but here, this number is exactly the same with or without the factory being destroyed. He gets the same thing in the case of a 40% yield because he has insurance and the insurance reimburses. Okay, all that said, we're pretty much done because now you rearrange this, well, not rearrange, but you plug those numbers inside the utility, and the utility was just whatever this expression was over there, 1 minus the exponential of minus W. And I think that's it. Well, maybe here there's one calculation to do to get to this line, but it's easy mathematics. Okay, so in the end, how do you solve for P? The last step is just to say, well, the maximum premium you would be willing to pay is the premium that makes the expected utility under the case of insurance equal to the expected utility without insurance, because any premium bigger than that would make his expected utility with insurance lower because he pays more. So of course his utility is decreased, and in which case he will just prefer to not get the insurance. Okay, so said otherwise, you put, well, okay, this is just equating. If you equate this utility, expected utility, with this, so expected utility without insurance, you equate this to the expected utility with insurance, and you solve for P, and this means that in both cases he has the exact utility. Okay? So any premium bigger than that, he's not going to be happy with insurance, and any premium smaller than that, he's going to be happy with insurance. So that's it. I think you will need to solve this equation, but it's a complicated equation, so you need some sort of numerical way, like the Excel solver, to solve this. And the last subpart, hopefully that was a little bit clear. The last subpart is simply a small conceptual question. Consider another situation where Ebenezer utility is now this function, okay, the exponential of W. Explain how this will change the maximum premium P that Ebenezer is willing to pay for his insurance policy from the previous part. Now here, this is just a conceptual point. Of course, exponential of W is now a convex function, meaning that the overall shape will be here. Okay, it increases, but it increases at an increasing rate. Okay, so it is convex. So this means in terms of utility, if this is a utility function, the more you have, the more an additional dollar will increase your happiness, right? This corresponds to what we called someone who's risk seekers. Okay, someone who actually likes uncertainty. A risk seeker person would prefer a gamble that's worth on average $100 compared to having $100 in their pockets, fixed $100, which is you can. This is a bit of theory revision, but why not? This makes sense in light of the shape of this utility function, because let's say that you have $100, and let's say that with probability 50%, you would win another amount, let's say another 100 or whatever, another 50. This would increase your utility by this amount. But if you were to lose this, let's just say that this is 50. Okay, if you lose 50, then you will lose some utility, of course, because utility is still increasing. Careful with this. Someone who's risk seeker still likes more wealth than lower wealth. But because they're risk seeker, if they were to lose this 50, they would lose more, they would lose less utility than the corresponding gain on the other side, than the corresponding gain in utility that they have when they win $50, which means, which makes sense of the fact that, yes, they would prefer a gamble where the average value is 100 compared to having 100 in their pocket, because they stand more to lose, they stand more to gain than they have to lose when they enter this gamble. Back to the specific question here, this just means someone who's risk seeker is gonna take insurance, but only if it's cheap. Okay, only if the premium, only if the premium is less than the expected value of the loss. Okay, but said otherwise, they're less willing to pay for insurance than someone who's risk averse. Okay, so here there's a lot of explanation, but here a student would probably get full marks if they just say he is willing to pay less, okay, a lower amount for insurance than if he has a concave utility function, because he enjoys the risk. Okay, he's a risk seeker, he enjoys the volatility. Now, again, careful, he might be willing to pay for insurance, but only if the premium is cheap. Okay, and certainly it needs to be less than the expected value of the loss. Okay, this is the opposite of a risk-averse person who's ready to pay a premium which is a bit more than the expected value of the loss. Okay, hope that made a bit of sense. If there's any other questions about this, you can reach out on the discussion forums. I'll stop here. And well, I take the opportunity to wish you well in your revision and in your life. Okay, so see you around. And I can't seem to find the button to stop the video, which makes it a bit awkward. Okay, I found it. Bye-bye.